Hi, everybody. Welcome to a new video of Lico and Zon. My name is Alex Palesandro, and I'm here with Alessandro Olivero. Hi, Alessandro.
Hi.
So today we will talk about service and service replication. In particular, we will see how Lico can allow you to replicate a service from cluster 1 to cluster 2 with really low frictions. So today, to do so, we will use two clusters on the cloud, one which is a K3S cluster and another one which is an AKS cluster. The first one is in a VM and the second one is on Azure. It is a managed clusters. So really quickly, we can install Lico on those clusters. So let's do this, Alessandro. Thank you very much. So we have, Alessandro, select the K3S driver for the K3S cluster and the AKS driver for the AKS cluster. licoctl is able to install Lico on both of them. It may require some extra parameters in order to grab all the information required by the Lico to run on a certain provider. Okay. So Alessandro, correct me if I'm wrong, but I think it will take a couple of minutes, maybe less. Okay, so the K3S is available.
It's finished.
Wonderful. And we just have to wait to the K3S. So it was around 30 seconds, K3S. I would say 40 for AKS. So it's important to know that licoctl does not only wait for pods to be available, but also for services. So for example, if there are services that have to receive an external load balancer IP, it will wait for them. Okay, I think we are done. So we have Lico installed, and now we can go ahead with our demo. So we will start not really playing with Lico, but just playing with a custom application, which is a very simple application, a very simple web service. And the basic idea of this web service is to share information about flights and share them from a public data set, which are the flights from New York in 2013. And we will see how we can share a service like that on a different cluster. So for example, we can create a pod. So it's very quick and dirty. We just create a pod with the Lico flight service image. And then we just expose it with a service. So we can have the same if this pod is put inside a deployment and so on. But this is just to be quick and effective. So we have a service which is now created. And we can, for example, spawn a new pod to consume it and see what it returns. So we use an image with the bin bash inside, and we will use curl again to contact him. So here you have the address of the pod, sorry, of the service, and we go to get the values from from this endpoint, from this web service. Here we have, so we have plenty of flights that are returned. And if you get, for example, the last one, we simply get the last one. So it's a very simple web service. Now let's try to replicate it on another cluster. So to do so, we have to establish the Lico peering. So let's go on the other cluster. We do the licoctl generated command. Now we can quit this first cluster and use the command to activate the peering. Very easy, very simple. And now we have this extra node here and the virtual kubelet that we described and discussed in the last video. So if you want to know more, you can have a look to them. And no, so now we have a LicoDemo namespace, which we just created. We didn't put any label on it, so it's a bit different from the other time. Today we want to have a custom behavior for LicoDemo. So we want to just to expose, just to make the service available without offloading pods. To do so, what we can do, it's really simple. We just use licoctl offload namespace command targeting LicoDemo with a bunch of options. So the first one is about how the namespace on the other side has to be called. And we say we want to have exactly the same name. Second, we want to prevent pods from going on the other side in this namespace. So we've put a pod offloading strategy to local. And the last one is about which cluster have to be selected for the namespace offloading, so for the namespace replication. And we just say, okay, we want to have our namespace just to be replicated on the clusters which have this label, which is lico.io/provider equal to AKS. And the provider that so the cluster we have here, AKS, it has this label. So the node here will have this label, and Lico is able to detect it and create the namespace on the right cluster. So let's try to do so. And we have now the namespace created here. And that namespace is the twin of the cluster, of the one in the first cluster. So if we have a look, for example, to the services that we have on the first namespace, we have the flight service. And if we look to the namespace just created as twin namespace, we have exactly the same service with a different IP. And this IP is different because in this cluster, we have a different space, address space for services. And so we have a different IP. But if you want to consume the service, we just have to spawn a pod as we did before and try to contact him.
We can show that in both clusters we can access the service in the same time.
Exactly. So this is on one cluster. Okay, and then we can
get the last one.
So if we copy on the other cluster, we can have the same. So the service has been replicated on the other cluster, and we can access it from the other cluster just by doing this licoctl offload. All the traffic will be transmitting using the VPN established at peering time. So there is nothing exposed by the cluster in some other ways. This is the Lico established this secure channel between the clusters and which transmit all the traffic between them. So it's pretty easy, it's pretty common, and it's pretty transparent also, because one application can just use the very same address of the service, very same URL of the service, and it will not notice that it is accessing a service which is somewhere else in the in another cluster. So I think that we are done for today. Thank you very much for your demo, Alessandro, and see you on the next video. Bye.
Bye.